Okay, so here's the first problem in the 4.5 task, and we are going to treat this problem the exact same way we just treated the last one. The first thing we're going to do is we're going to find all of the main features that we learned how to do in class. So the first thing we're going to talk about is the x-intercept. Notice that the numerator here has no x in it. That means that there's no way to make the numerator equal to 0, so there actually is no x-intercept. So when we plot on this graph, we're never going to hit the x-axis with this particular function. The y-intercept, we can find that by plugging 0 in for the x's. So if I do that, we'll get a 4 on the top. On the bottom, you'll get a 1, which means you have a y-intercept at 4. So that's the coordinate point, 0, 4. Vertical asymptotes still happen where the denominator equals 0. So that's going to give us a vertical asymptote at -1. Proper versus improper. Since there's no x in the numerator, that's actually a degree of 0. The denominator is linear, so that's a degree of 1. That means that the degree on the top is smaller than the bottom. Anytime that's true, we have a proper fraction. Because we have a proper fraction, that means the end behavior on both sides of the function are going to go to 0. That happens anytime you have a proper fraction. Because I have end behavior that goes to the same number on both sides, that means I actually have a horizontal asymptote, and it's the same as what the end behavior number was. So it's 0. So piecing together what we have so far, I know that I have a y-intercept at 0, 4. I know that I have a vertical asymptote at -1. I know that I have an end behavior of 0 and a horizontal asymptote at 0, which is the x-axis. So piecing together where we are on the graph, since I'm never going to hit the x-axis and I have a point up here, that means that this left or this right-hand side of the portion of the graph, this is going to have to be above the x-axis. And because of the rule with rational functions and their end behavior, that means that this is going to come down and it's going to follow towards the x-axis forever. On the other side of the x-axis, or the other side of the vertical asymptote, I should say, if you want to figure out whether you're going to be up top up here or down below, all you need to do is plot one point. If you get a point that's above the x-axis, that means this entire part of the function will be above the x-axis. If you get a negative number and it's down here, that means the entire portion of this function will be below the x-axis. The reason why you know that you don't hit the x-axis ever is because we see right here that we have no x-intercept. So I'm going to come down and I am going to plot 1 point. So to the left-hand side of the vertical asymptote, a number like -2. So I'm going to plug -2 into the equation up here. And we will get a y value of -4. So we have a dot down here. So what that means is, since I got a dot below the x-axis, that means this entire portion of the curve is going to remain below the x-axis. And so what I end up with is 2 branches of my curve, just like in the last problem. So if I want to state my domain, again, all real numbers, and then x cannot equal any vertical asymptote values. So x can't equal -1. If you want to do interval notation, you would need to go -∞ to -1, and then pick up from -1 to +∞.